Today, we would like to welcome you all to our very exciting educational session, Filling the Gaps by Publishing Negative Results in Genetics. This is an exciting opportunity to learn and participate in a discussion about negative results. The definition of success in research is largely attributed to publishing hypothesis-driven positive results. However, we know that science has always advanced by learning from past failures. So what are negative results? Why are they important? Are we really encouraged to talk about them by our mentors and by the leading journals and field experts? Is there a bias in our peer review process, and do journals often force researchers to only submit novel, positive results? What does it mean for our research funding and grant applications, and how truthful we are when we are writing them?
In this session, you hear about negative results and the related issues by two excellent speakers, Dr. Devang Mehta and Professor Regina Arechavala-Gomeza. We greatly thank you for accepting our invitation. And after the presentations, we will then have a panel discussion with the speakers and two editor-in-chiefs, Dr. Madeleine Skipper and Dr. Alistair McNeil. And thanks to all as well for accepting our invitation.
Our first speaker is Dr. Devang Mehta, a postdoctoral fellow at the Department of Biological Sciences at Faculty of Alberta, Canada, and incoming faculty member at KU Leuven. As an early career advisor, Dr. Devang has highlighted throughout his academic career the impact and need of discussing publishing negative results. He will be joining us through a pre-recorded talk on honesty in science, why negative results matter.
Good morning, everyone, and welcome to this remote lecture on honesty in science and why negative results matter. Before I begin, I want to convey my thanks to the ESHGY committee for organizing this session, and in particular, Midul and Juliana for helping me pivot to a virtual participation as I'm unable to attend the conference in person. I'm Devang Mehta. I'm a postdoctoral fellow at the University of Alberta and will soon be a faculty member at KU Leuven in Belgium. And I'm also, more pertinent to this conversation, I'm an early career advisor at eLife, which is an open access publisher in the life sciences. So today I'm here to talk to you about honesty in science and why negative results matter. So before I begin, I wanted to kind of start by setting a common definition for what a negative result is. I think it's important that we have a clear understanding of what I mean when I talk about negative results. So if you consider an experiment, so this can be any experiment in the social sciences, psychology, wet lab science, dry lab science, GWAS, and human genetics, any experiment, there are a range of possible outcomes that experiment can have. One of these outcomes is that you have an expected or desired result at the end of your experiment. And this is, of course, a very positive outcome. It means that your initial hypothesis has been validated, or the technology you developed has proved to be effective. The drug that you developed works as planned. All of those results can be grouped under kind of the positive result umbrella. Then there's a kind of more common set of results that I'm not going to talk about today. And this is when an experiment is invalid. So you have an invalid result, an incomplete result, something that suggests that something was wrong with the experiment, the study protocol maybe wasn't correct or needed to be followed a little bit better, the environment changed partway through an experiment. Any of those circumstances that results in an invalid result. And this is not what I'm going to talk about when I talk about negative results. Then you have a third possible range of outcomes. And this third possible set of outcomes is what I consider the negative result. And this is a range of outcomes where, for example, your study can support the null hypothesis, your significance threshold is not met, and you say that your study was negative because it supported the null hypothesis. You could have a study that contradicts the existing consensus. You have a study where the results are negative in the sense that they're proving a negative. They're proving that a previous hypothesis was wrong, a previous study was wrong. And then typically a negative result is also a bad outcome for someone. It can be a bad outcome for the community that had invested a lot of time in validating a particular hypothesis. It can be a bad outcome for a company that had invested resources in developing a particular intervention or drug. So all of these outcomes can be, I think, grouped under the negative result umbrella, and that's what I'm going to talk about today. So the reason I'm talking to you about this particular topic is that I've talked previously and written about my own experiences publishing negative results. And this was an experience that stemmed from my PhD. I did my PhD, completed my PhD 4 years ago at ETH Zurich in Switzerland, working in a plant biotechnology lab. Our entire goal was to try and engineer plants to make them resistant to pathogens. We were working on tropical plants in particular, and one of the papers from my PhD ended up proving a negative. It actually showed that a particular technology for engineering plants for pathogen resistance was ineffective. And it actually disputed previous results that have been published that suggested that the technology would work. So it was clearly a negative result. I'm not going to go too much into the details about my science. You can read about it in an article I wrote for Nature's Career column previously, or listen to an interview I did with Deutschlandfunk. This experience, while trying to get our results published, our negative results published, we faced a few drawbacks. The first was that the journals that initially published the positive results by other researchers declined to publish our contradictory results. And in many cases, I think this was because of biased reviewing, where reviewers really did not want to believe in our results, did not want to believe that our results showed a negative outcome for that particular technology. So that was why I believe, in my opinion, a couple of these journals rejected our paper. In the end, to actually get our paper published, we needed an explicit intervention by a member of the senior member of the editorial board at one of the journals that we submitted to. And this is someone who's a very senior figure in my particular field of research. They are a fellow of the Royal Society, for example, so a fairly well-established scientist. And they believed in our results, and they finally led. They were not involved in the study, but they really championed the publication of our paper. And eventually our paper was published. It took 1 year and 7 months, which I know in the larger scheme of things is not a very long period of time for publication. But for me, as someone who was finishing their PhD, needed to apply for postdoctoral fellowships, it was a fairly difficult period of time trying to get this paper out. And we had to eventually approach 4 different journals before the paper found an appropriate home. Now, when I went through this experience, I realized that our experience wasn't unique. I found many different articles written by other scientists who had gone through very similar experiences. I've listed some of them over here, a couple of them that I found extremely interesting. One by Stephen Curry, who's a biologist at Imperial College, a structural biologist, as well as a paper here on retraction watch by David Wu. And these experiences had some commonalities with my own experience that I found were very interesting. One of these commonalities were that these papers that seem to report negative results end up spending a lot more time on the journal train, where they go from one journal to another journal to another journal, till they find an editor who actually believes in the value of publishing those results. And this seems to be common across papers with negative results. Journals that publish positive results, so the journals that initially publish positive results, rarely seem to be willing to publish contradictory findings or findings that contradict the studies. And I know that this is kind of a controversial statement that maybe some editors might take issue with, but I think in practice it seems to be the case where many contradictory findings are not published in the same journal that initially published positive findings. Something else that we experienced was that negative results are required to meet a much higher bar for publication. Reviewers and editors demand a lot more follow-up experiments, demand a higher level of statistical rigor, or a higher number of replicates, for example, to have those negative results compared to positive results. And then finally, the experience of publishing negative results seems to have a pretty large impact on the scientists involved. So this is not just me, but my colleagues, but also these other scientists who have previously published negative results and had the same experiences. And I think a lot of the time, the reason for this is that going through the process of trying to publish negative results, at least for me, it really shook my faith and my trust in the scientific process. Because as a PhD student, I'd been kind of trained or sensitized to this approach of science, where science is an unbiased thing, where peer review is rarely is often objective, or it's expected to be objective and unbiased. And this entire experience really shook my faith in that process and really showed me how bias can play a role in publishing, how subjective a lot of the publication processes are in many journals. And often this is why scientists like me end up talking at events like this and trying to disseminate our own experiences and learnings from this publication process. Another thing I discovered when I was looking through some of the literature around publishing negative results was that while in my particular field of research this isn't really talked about a lot, in many other fields of research, publication bias is a very well-established phenomenon. And this is particularly true in fields like epidemiology, fields like psychology, and in particular clinical research, where publication bias is a recognized form of bias in science. And publication bias is defined as when the outcome of a particular experiment or study biases the decision of whether that paper should be published or not, whether those findings should be disseminated or not. And the first time I read this, it was a real revelation that scientists had actually documented and come up with ways to combat this bias. But it was also a very interesting finding for me, because in my own field of research, in more molecular biology research in the wet lab, it's kind of a normal phenomenon that the outcome of a study should determine the publication venue or whether the paper is published. This is considered normal in my field, but it clearly isn't normal in many other fields of research, in particular in clinical studies, as I'll talk about in a bit. Another kind of realization that I had at this point was that publication bias is kind of a feature of the current system of academia. It's built into the real skeleton of academia today, where the impact of your study, the results of your study, determines whether you have a successful career in science, whether you have additional funding, and this really reinforces this bias of publishing only positive results. So this is an inbuilt feature of the academic system today. I also started discovering some more interesting primary literature into publishing negative results. And one of these papers that I want to highlight today is by Daniele Finelli, who's a meta-researcher at the University of Edinburgh in Scotland. And in this particular study that was published in 2012, Dr. Finelli looked at 4,700 papers that had been published over a 17-year period, and he found a 22% increase in the proportion of papers that reported positive findings. And in fact, he found that 85 to 90% of papers in biological fields reported positive results. So this is a real problem. It's not, my case and the case of others are not exceptions. It really seems to be the case that science is trending towards more and more positivity. And this, I don't think, is a very good thing for science. And the reason for this is that I believe that negative results are more important to science than positive results. I think if you look at this historically, I think negative results are the results that have spurred the greatest shifts in our paradigms in science. They're responsible for many of the fundamental discoveries and the ways in which we think about the natural world today. And this is particularly true in fundamental science. And one example I wanted to bring up today was this famous experiment, which might be familiar to those of you who have an interest in physics or remember some high school physics. This is an experiment called the Michelson-Morley experiment that was published in 1887. And at the time, back in the 19th century, scientists believed in the existence of something called ether, which was a medium through which light waves were supposed to travel, the way sound waves require air or some other object to travel through. And this particular study was designed in order to prove the presence of ether and to study the impact that ether has on the change in the speed of light. Now, despite repeating this experiment several times, the two scientists involved, Michelson and Morley, kept receiving a negative result. They did not see any change in the speed of light, irrespective of the way in which the experiment was performed, suggesting that there was no such thing as ether and that light can travel at a vacuum and travels at a constant speed. Now, this was a fairly major study, a major finding in modern physics, and in many cases it's considered the most important failed experiment in science because of the impact that it had in the development of modern physics. And this is just one example of some of the more foundational studies in modern science that have really reshaped the way the scientific consensus in many fields of research. So this is just an example for how important negative results are to fundamental scientific advances. But negative results are also important in applied science. One example for this is the fact that negative results are absolutely essential to evaluate drug safety and efficacy. And scientists have looked into how negative results are handled in the case of drug evaluations, for example. And in this particular study that I want to highlight, looked at papers that were submitted to the FDA, studies that were submitted to the FDA, which is the Food and Drug Administration in the US. And the FDA requires people who apply for approval to pre-submit studies to them. And then the FDA evaluates those studies and comes up with a decision about whether that particular intervention, that particular drug had a positive effect or was not effective. After the FDA comes up with the decision, the authors or the people who submitted those particular studies then have the choice of whether they want to publish those studies or they don't publish those studies. And in this particular paper that I'm going to be talking about is basically a very foundational study in the field of studying negative results that was published in the New England Journal of Medicine in 2008. And in this particular paper, scientists looked at how the FDA evaluation of antidepressant trials correlated with the eventual publication of those trials in published literature. And this is important because when doctors decide whether they need to prescribe a particular drug, they can only look at the published literature to decide whether that drug is effective for their particular patient or not. And in this study, what the researchers found was that when the FDA looked at a set of studies and they decided that a set of studies actually had a positive outcome, 97% of those studies ended up being published subsequently in journals. So here, 37 out of 38 studies that the FDA said had a positive result, it ended up being published in a journal. When you look at, however, the subset of articles or studies that the FDA considered to have a negative result, 67% of those studies were not published in a publication. And 21% of those papers that did get published were published in a way that conflicted with the FDA's own decision on the efficacy of that particular intervention. So this was a very important study, in my opinion, that really documents how negative results and the bias against negative results can change and can have an impact on the published literature, which might eventually result in changes in how doctors behave when they try to prescribe particular drugs. So this brings me on to kind of the next point, which is that when I talk about negative results with many scientists, when I talk about this phenomenon, especially with scientists who've been in the field for a long time, they often raise the point that science is self-corrective, right? So eventually, over time, the truth will always come out. The scientific consensus will change over time. New results will be accepted by scientists. But my point is that while science does eventually self-correct, there is a potential for a lot of harm when the self-correction process is delayed. And this happens when negative results are delayed in their publication. And in fact, Me, as well as my PhD advisor, Hervé van der Schuren, whom you will hear from later in today's session, recently published an article looking at our own field of research in agricultural biotechnology, where we really looked at and made the argument that the self-correction process in science is often delayed when it comes to applied science in our particular field of research. And we came up with a kind of a framework for our argument over here around the hype cycle. So the hype cycle is a concept that we borrowed from technology studies, where it's fairly well recognized that when a new technology emerges, there's often a kind of peak of inflated expectations where the developers of a technology hype it up to such an extent that people have expectations that far outstrip the actual performance of that technology. And then you have kind of this trough of disillusionment when some kind of negative results start coming up about that technology before a new consensus is achieved. And we believe that there is a similar scientific hype cycle where you often have positive studies coming out that have over-promising results, that really over-promise on the impact of their results. And then over time, yes, people will come up with negative results, and those will emerge eventually, and then you will have eventually a new consensus forming. The problem is that the x-axis in this graph is time times money. And this is because the longer you delay the publication of a negative result, the more money other scientists are investing. And this can often be, in our field, scientists from developing countries, scientists from countries like my home country of India, or partners in Africa, who are investing limited resources in trying to develop further the advances that were promised by the first positive study. And in many cases, they do this before the initial negative results are published because of the delay in publishing negative results. So this can really lead to concrete harm to the scientific resources of many developing countries, researchers in developing countries, as one example of the kind of harm that's caused. So what are potential solutions to this hard problem of how to spur and encourage the publication of negative results? In my opinion, this has to be led by journal editors. Journal editors need to take concerted action where they commit to accepting papers that have negative results, that contradict earlier results published in their manuscripts, in their journals. Editors, I think, when they publish the initial positive, groundbreaking, extremely promising study, should also commission contextual critiques of that study at the same time. Typically, you will see articles that get published in high-impact journals have accompanying news and muse articles, but those are very positive articles, and I think that should be changed. We should have critiques already at that point in time, which kind of rebalances the way in which the community perceives a particular paper that's published in a high-impact journal. Something that I think a lot of journals have started adopting that I think is a positive change in science is that journals like Cell Reports and Science Translational Medicine now encourage authors to include a limitations section in their manuscript, where authors can have the freedom to explain the limitations in their own research. And this, I think, would be an important solution for preventing positivity bias in science. Finally, I think natural science disciplines like my own should adopt practices that are more commonly used in clinical research. Example of this is pre-registration, where you can pre-register a study design with a journal, and then the journal commits to publishing the results of your registered study, irrespective of whether it's a positive or negative result. I think this is an extremely powerful way to combat the bias against negative results. And in the long term, I really think that the bias against negative results, the bias towards positivity, is a side effect of our culture of prestige publishing. And we really need to eliminate this phenomenon where we publish based on prestige, and we really look at the prestige of a journal when we evaluate how we look at papers. And journals and publishers are looking at changing the existing models of publication. One very promising model is at eLife, I wanted to highlight, is a publish and then review model of publishing, and I encourage you to look up this editorial. So I wanted to conclude by giving you some more practical tips. So suppose you're a grad student or postdoc in the audience today and you have a negative result. What can I tell you from our experiences? What tips can I provide in helping you publish your negative result? The first thing I can tell you is that you do need to come up with an alternative hypothesis and at least do a preliminary test of this hypothesis. This is something that I find a lot of reviewers will demand from you when you want to publish a negative study that contradicts another study. The next thing that you can do is share your work with the community. One of the best things that's happened to science recently is the emergence of bioRxiv in biology as a platform where you can share your results before they get published in a peer-reviewed journal. And this, I think, is an extremely important step to making sure that negative results receive the attention that they merit immediately as soon as they are realized. And there is a reduction in the delay between positive results and negative results. And then finally, this is kind of a more political statement, but I think it's important to have allies in the community, especially powerful senior scientists who can help you get your paper published in important journals. And then finally, I can only say that you need to prepare for battle. The process of publishing a negative result is taxing mentally, it's draining emotionally, and you do need to prepare for that battle with reviewers, with editors. The timeline that's involved in publishing those results can also take a toll on your mental health. And then finally, I can say that, once you go through this process, I encourage you to join different communities around the world that are working on reforming the academic system so that we no longer have to deal with publication bias in science. So some of these networks are the eLife Community Ambassadors Network, which is a group of over 500 scientists now, the ASAP Bio Fellows Program, as well as early career reviewer boards that many new journals have started up. Many journals have started up recently. I encourage you to get involved in science publishing and take a leadership role in academic science and change academia for the better. And with that, I'd like to thank you very much for your attention and for hosting me at ESHG. I hope you have a great conference ahead, and I hope you have a great discussion following this talk as well. Thank you very much.